Okay, so today I'm going to explain you the very important topic of Splunk, how to deploy the group of non-clustered indexes. So as you can see in this uh, on this page, I would suggest to just focus on this part for now, just the universal forwarder and then the indexer. We'll come to search head later in my next video, how to set up the uh, standalone search head. That will be pulling out the data from these indexes. Okay, so if, as you can see, there are two forwarders. And before I start, I would suggest not to skip or forward it to understand the topic in detail, how the non-clustered indexers works and what are the main disadvantages of setting up the non-clustered indexes. So as you can see, there are two universal forwarders and there are three indexers, right? So like in simple environments, you might have set up or you might have seen that there might be set of universal forwarders posting the data to a single indexer, and that indexer machine might be acting as a search head as well. So it's uh, I would say kind of from mid-level of a Splunk environment wherein we need to deploy more than one indexer. But here we are not going to deploy the clustered indexer. So these are the non-clustered indexes, and I'll show you in practical as well how it works. So what will happen if you make the indexer non-clustered? It means these forwarders, right, EF1, EF2, these will be pushing the data to these indexer groups, but there will be just one copy of the data. For example, based on the availability of these indexers, if EF1 push an event to indexer 1, then that event won't be replicated to any of the other indexer, indexer 2 or indexer 3. Similarly, if EF2 pushes any event to indexer 2, that event won't be replicated among other indexers in the group. So the main disadvantage is that if any of the indexer machine goes down, or if the machine uh, gets terminated, that data will be lost completely. You won't be able to uh, pull that data using search head, right? So that's the major disadvantage of using non-clustered indexes. In terms of benefit, uh, I would suggest to use it if you feel that your data is not that critical and you do not want to consume more of the space on the server. Then obviously you you may consider setting up non-clustered indexes. In that case, since you are keeping just one copy of the data, it will require less storage and compared to the clustered one, wherein you need multiple copies of the data, right? So, okay, so that's the overview of non-clustered index. Now let's see how to set up this. So these EUPs, we will be setting up all these indexer configurations on EF1 and EF2, and then the Splunk manages it on its own to balance the uh, network calls, right? And based on the availability of the indexers, it will be pushing the logs to any of these indexers. Okay, so I have already configured 5 instances on AWS. So 3 of them I'm going to use them as a full instance of Splunk, and so those are going to act as an indexer, and the other 2 are going to act as an universal forwarder. So these are 3 standalone Splunk full instances as of now, because we have spinned up the machines on AWS and then installed the full instance of Splunk. So for now, if you see, all of these instances have their own internal logs. There is nothing else coming. You see just one host, right? So it's pushing its own internal logs for now. Okay. Now, and here on the back end, if you see these two machines, which I have configured as I've installed the universal forwarder. If you see here inside this system local, there is no outputs.conf, right? So I haven't configured uh, uh, any indexers here, like where this machine has to push the data. So similarly here, if you see, there is no outputs.conf. Okay, so let's do that one by one. On the indexer machine, let's enable the receiving. And we are going to use the default port only, 9997. Okay, so this machine is ready to receive the data. Okay, so on all these three indexers, if we enable the receiving on the default port, that is 9997. Let's create one sample index as well. So test index. Let's do it on all the three indexers. And keeping the default settings, just changing the storage size. Okay, if the receiving is enabled, now we need to configure the data forwarding from these boxes where the data is residing. So we have installed universal forwarder here on this machine and this machine, right? So here, to do that, you just need to execute this command, or you can directly create the outputs.conf. Let's do this way. So this is the simple command which you need to execute in order to configure the outputs. Splunk add forward server, and then you need to give the IP of your indexer, which is this one. Paste it, and the receiving we have enabled on port 9997. Let's do that. Asking for the username password. Okay, so this is added. Let's add all three indexes. The third one. First, we have enabled the receiving on the default port 9997 on all three indexes, right? Okay, so now if you go to etc system local, earlier we were not able to see any outputs.conf here, right? Now, after adding the forwarder machine, we can see this outputs.conf has been created. And you see all the indexers have been added here. 1, 2, 3. So all of them are part of the outputs.conf now, which means this machine is ready to push the data to all these three indexers. Let's do the same thing on the second universal forwarder. provide username password. Add the second indexer. Add third index. Okay. Okay. Let's go to indexer. Let's see if you see any change here. If you see now, you can see two hosts, right? So one of the universal forwarder started reporting to this indexer. The same case here. This none of the universal forwarders are reporting to this indexer as of now. And that's what we expect from the non-clustered indexer. Based on the ability to balance the load, it will be calling any of the indexers in the group because it's non-clustered one. It's not going to replicate the data among all the indexers available in the group. So that's how it's working. But anyway, to test it further, let's create some sample log file. Here inside OPT, I'm going to create a test.log file. Put one simple line. Just one EF1. Okay, and create the inputs. Inputs.conf. For that, the stanza is monitor. Our file is inside OPT, and file name is test.log. Index and okay, index. You can keep the common index for all your inputs. So defining it on the top. Monitor, and then source type also you can define. Logs level equal to 0. And in fact, you can pass the metadata as well if you want. So like here, if I give host name EF1. Okay, so this is done. Do the same thing on second universal forwarder. It is .log logs 2 and create the inputs. Index we are going to use test only. Create the monitoring stanza. Okay, test log. Just see. Okay, test logs. and meta. So here we are using EF1 hostname. Here we are going to use EF2. Okay, so this is done. So now we have configured the inputs on both EF1 and EF2. And since we made the configuration changes, let's restart Splunk daemon on both of these forwarded machines. Okay, so here restart it. Then here too. Let's go to indexers. So this is our indexer 1. Let's see if we have any data here inside test index. Okay. So as you can see from universal forward 2, the data has been ingested on indexer 1. Let's check on indexer 2 if anything is there. Nothing has been ingested there. And from universal forward of 1, the data has been ingested on indexer 3. So I hope we are understanding the logic, like how it's working, right? It's working based on the availability of the indexer. It's just balancing the load. And the data, it's going to ingest the log only on one indexer. The data is not going to be replicated among all the available indexers. We'll see this part later in the next video, but I'm just trying to explain this part here. That how the universal forwarder posts the data to the non-clustered clustered indexer. Now let's try to create another line in the log file. Okay, so let's new line. So here's one. Do the same thing on universal forwarder 2 as. Okay, now let's go back to the indexer and see where those events have been ingested. And it's not mandatory or necessarily that the second line, what we added there on EF2, that will be ingested on indexer 1. Let's see. That's not added here. Okay, so this is indexer 2, and if you can see, both the new lines we added, right, those are ingested to the indexer 2. So nothing on indexer 3, the new line what we added, that's not added to indexer 1, not to indexer 3, but both those lines ingested to indexer 2. So that's how Splunk is balancing the load among all the uh, available indexers in the non-clustered group. And the disadvantage, as I said, if any of these indexers goes down or gets terminated due to XYZ reason, then the data will be lost completely. So it's not advisable to put to use non-clustered indexes for any of the critical data. But if you feel that the data is not that critical and it can be restored and re-ingested, in those cases, you can go ahead with the non-clustered indexer to save some storage cost. Okay, so yeah, that's it. I think for this session, I just wanted to explain you how the non-clustered indexers group work. This part here, let's see in the next video how to configure the distributed search. So now, as you can see, as of now, we are able to search only the ingested data here, right? The data which is ingested on indexer 1, we are able to see that here, similarly on indexer 2, indexer 3. But I want to set up a standalone search ad wherein I want that to populate, to pull the data from all these three indexes. So we'll see that in the next video, how to configure that. Okay, thanks.